So I'm Sam Vanhoutte. I'm from Belgium, and I'm working as CTO in the company Coded. So we are based out of Belgium, France, Lisbon, Switzerland, and since this week also in UK. We focus on Azure solutions, IoT solutions, API management, but of course we stick true to our roots, and that's of course integration. So this talk will be mostly about Service Fabric. And of course, Service Fabric is probably not the first thing that you would expect in an integration conference, but I'll explain you why I picked this topic. So I'll do a quick introduction, positioning of Service Fabric in the overall Azure landscape. I'll dive a little bit into the architecture, talk about concepts, and then in the end I will talk about some projects that we have done with Service Fabric and some reasoning, because I hope you can learn some things of best practices. We only have half an hour, so that's really not a lot for this complex topic. So don't expect a deep level. I also don't have demos normally, unfortunately, because I love to do demos. Anyway, Service Fabric actually exists for quite a long time already. Microsoft has been using Service Fabric inside the Azure data center for a long time. So we see a lot of the services they have been building upon on Service Fabric. And what they have been doing in the past 1 or 2 years, involving a lot of partners and customers, is taking their internal stuff. So Service Fabric was really something they used internally. They tried to make sure that it could be used by partners like us. And that, of course, means better documentation, more consistency, maybe security even had to be better and things like that. So now they had a big process of taking their internal product and making it user-friendly for people like us. There's a lot of partners that have been playing with this. A lot of these partners you might recognize are also integration partners. And of course, that's because it has its place. Service Fabric is really something to do a lot of work in the cloud to glue a lot of things together. So here's the word, Microsoft. The word because it's very loaded, but still, the vision is that with Service Fabric, they want to move away from the monolithic applications, and the big problems with that were scalability and the complexity of deployment. Like if I want to have this monolithic application installed on 3 servers and suddenly one of these components is not scaling enough, I have to add an extra machine, even though if it's only that specific component. With the Service Fabric approach, you can have your application split up in a lot of services, and these services can be spread out and partitioned over multiple servers actually. And the best thing to compare this with is if you have been using cloud services in the past, and we have been doing that since 6 years or so, what you could see is that for every service you had, or role it was called, like a web role or a worker role, you had at least one virtual machine that you had to deploy that role on. So even if I had a very small background worker that had no scalability needs, at least I had to deploy it on one machine, and actually if you still want to make it high available, you had 2 machines. And that was quite costly. So what we had to do for a lot of projects was, instead of having one service in one role, we had one role that dynamically created multiple tasks that run in parallel, and that's quite complex to maintain for custom projects. So with Service Fabric, it's again better because you can just deploy your services independently from each other, and you don't have the limitation of at least one virtual machine for one service. You can have one service deployed on 10 machines, and one machine can contain 10 services, instances. So that's important to understand, that you have much more higher density than you used to have with cloud services. And that's already a reason why I would say now to customers or even partners, if you have things that you had to do in the past on cloud services, worker roles for example, I would move them now to Service Fabric because it will typically be less costly, and you have still the more granularity you typically want to have. One thing that's important is also the concept of node types. So these machines, you can give them specific node types, and they reflect in scale sets. And you can say, okay, for these types of microservices, I want to have a high memory machine, and then I have a high CPU machine for a lot of background threads and things like that. So you can really deploy and say, okay, this type of microservice has to run on a virtual machine of this node set or node type. And then you can say of that node type, the high memory machines, I want to have 10 machines. And you can scale up and down. We will talk about that later. One thing that was not possible in the beginning, in the previews, was to have less than 5 machines for your Service Fabric cluster. So a lot of people, especially for scenarios where you don't necessarily need the scale. I mean, not everyone is building, event hubs. Not everyone is building the new Facebook. Some people of us just have to do some lightweight workers, and you don't necessarily require the scale, but still you want to benefit from, the microservices approach, or just the, the isolation and granularity of all these things. And for that, recently they introduced the fact that you can deploy your virtual machines to 3. So you can have a minimum of 3 machines using the bronze reliability tier. Still, they require, or they say that they consider it as a test cluster, right? But at least your dev test machines, you can run them on 3 machines instead of the 5 we had before. Now, what happens? I had a question, I think, yesterday about, is this actually platform as a service? Is it infrastructure as a service? Because you indeed have virtual machines that get deployed into your resource group, and then you deploy things on top of that, and you can scale machines out and up. So is that platform as a service or infrastructure as a service? And the good thing is, it's both, and I think it's best of both. So if you want, you can just take the full platform as a service approach and go to your Azure portal. You can say, I do a file new Service Fabric cluster. You say, that, you do all the configuration, and the machines are deployed into your subscription. And they are also, upgraded. If there's patches on the OS, if there's new versions coming out, they can get upgraded just like that. But the good thing is that you can also run Service Fabric everywhere. So you can run it in your own data center on-prem. You can install 5 servers. You can deploy your Service Fabric to that. You can also do that even on the other clouds, Amazon, for example. You can run it even on Linux servers, although these things are still in private preview, but that's the intention. So the good thing is that actually you can build your distributed solution. You can develop it once, and you can deploy it in almost everywhere. You can deploy it in the different clouds and so on. And for a lot of customers, that can become important. Some customers don't want to have that lock-in you sometimes have with the pure PaaS platform as a service we had in the past. Now you can say, no, we use Service Fabric as the backend for that solution. And if you're not happy or you don't want to have that lock-in with Azure, you can still move it to your data center. And that's something important to understand with the Azure Service Fabric Everywhere program. Now, how does it work? You have 1 or more apps. They exist of services, and you can deploy them to virtual machines, to your cluster. And again, these services are just spread out over the available machines. So at this point, I have 6. If I would have 7, they will scale out, and repartitioning happens. Now, of course, what's important is that at a certain point in time, things will break, so that one specific machine can fail. And you will see that immediately services are repositioned. And you have primaries and you have secondaries. So there's always one service that gets called, one service instance, and if it's stateful, for example, it has its state replicated to other nodes. And I will come back on things like that. Now, one of the most important things you have, and it causes quite a lot of confusion, is the different types of programming models you get with Service Fabric, especially in the beginning. So with the early things in the preview, you could really see that there were like 2 different teams or something inside Microsoft that you had the actor model, which we see on the bottom, and you had the services model, and a lot of things were not consistent with each other. They did a lot of work on making sure that the programming models are now, and the object models are now getting more, look-alike. But still, it's important to choose the right, thing. So you have services and actors, and you have stateless services and stateful services, and I will discuss them. So the first thing is if you go stateless, and that's what we have been doing for the past 20 years in a lot of cases, where you just have your web API and things like that, and the state is typically somewhere else. You have your SQL Server, you have your table storage, whatever. That's a very common and existing approach. And the good thing is that your services in a stateless manner, they can be spread out over all these machines. It doesn't matter if the first call from an API is coming to node 1, and that second call is coming to node 3, because they are stateless, they don't care, where the previous call went. So that's out of the box pretty scalable. And that's with load balancing typically. Now, if you go stateful, you simplify a lot of things in a lot of cases. You put the state with your logic in a lot of cases. Again, it has some challenges. I'll be talking about that later. But your state is stored with your service. And if you go stateful, it also means that if your service crashes, that state will move to another node. So your state is reliably mirrored to other nodes. And that's very important. And once you go stateful, it's very important to understand the impact of partitioning, because the total state that is deployed in your cluster will still be partitioned based on an algorithm that you can define. So you can partition based on city, you can partition just based on random hashing algorithms. You have control on that. But it's really important to consider the right partition algorithm, because in a certain moment, if you have one peak, and you, for example, in football games, and you have that one specific game that you have to host, and you partitioned on game, it would mean that Champions League final, that all the requests of that, if you partition by game, all those requests for that game, and that could be very high, are still going to the same partition, and you don't have the big scalability. So that's really something where partitioning, and sometimes if you don't think about it, it's like one developer that just defines, this is the way I will do partitioning. No one starts thinking about it, and you can have scalability issues. And then, of course, you have the services. So services is what we know mostly. So you can have the activation and background work. If you think about worker roles, they have the run method. Well, services also have a run async that is constantly doing the background work. What they also have is communication listeners. So you can open endpoints, HTTP, TCP, custom things, where a service itself is opening a communication listener so that it can communicate and receive requests from the outside world or from other microservices. If you go with stateful services, you also have transactions to update your state. So your state is distributed over those machines, and you can update in a transactional manner, and that's important. So you can say, I will update this collection, I will set the message on a queue, and now I will commit, and everything will happen, or just roll back. And that's with the reliable collections. Now the other thing, and a lot of people, they see Service Fabric, they see that actor model, and they just want to start with actors, and I was one of those people in our company as well in certain projects, because actors are, it looks simple, it looks like the new thing, and you want to start with that. And in a lot of cases, it has its advantages and its place, but you have to take care of the right scenarios. So simplified programming model, that's really the case. Why? Because it's single-threaded, and it's turn-based. So you know that if you're listening or if you're updating your state for your specific actor, you will be the only one at that point updating that. So that's pretty easy, because all the concurrency issues that you might have are handled by that load balancing internally from Service Fabric. Before GA, because Service Fabric was generally available, I believe, on the Build conference, before that you had explicitly stateful actors and stateless actors. That has been changed. Now you just have actors, and then on the bottom here, you can specify on an actor how it's persisted. You can say it doesn't have state persistence, or it has persistent state persistent, and that means that the state will be distributed and stored on the disks of the Service Fabric cluster. And you also have volatile. It means the state is still replicated to all the other nodes, but it's kept in memory. It's not written to the persistent state things. Now, that's the theory. The other one that I forgot here, you can also bring your guest executables. So if you have that old, I don't know, XML to PDF.exe program that you still want to use in your application because of, I don't know, time limitations and whatever, you can bring that exe. You can make it as a service. So you just define it in your service manifest XML. You deploy that with your application, and it will also live on that cluster. It, of course, cannot talk with the cluster because it doesn't have the programming model, but other services can call that exe easily. And that's something that's also possible with the guest executables. Now, when do you use what? I would say stateless services is what we have been doing mostly. That's API type of things, web front ends, protocol gateways that just receive requests and pass it on to either actors or stateful servers, and also background workers, where you do constantly listening on something and acting based on the event. Now, stateful services, I would say if you have data that you want to keep with your services, that's of course the way forward. Stateful receivers, what I mean with that, for example, if you have partitioned receiving on things like Event Hub. Event Hub has its own partitions, and if you saw the talks of Dan and Clemens, you see that you have to keep track of your own bookmark, like your offset. I'm reading on partition 1, and I'm now at, I don't know, message 15. That's something that you typically would store in your own state of your service, so that if you crash, if you move to somewhere else, that you start on the right offset again. So that's a very common approach that we have used ourselves. Of course, caching is very important. Queuing is out of the box. And then we go with the actors. So stateless actors is something that we didn't have a lot of real cases for. That's also probably the reason why it's removed from the Visual Studio things. We see some scenarios where you just say, okay, I want to trigger something, like fire and forget, a short-lived thing. That's where stateless actors could be helpful. But mostly, if you use actors, they will be stateful. And what we see there, we sometimes relate them to functional entities. So for example, in IoT scenarios, we have a specific light in this room of that building, and we can really have those defined as actors, and they can communicate with each other. And the good thing is that they are single-threaded, but if it's, for example, your shopping basket, I think that's one of the scenarios as well, but it's just you and your shopping basket, it doesn't matter. It's very easy to just add items. It's not that suddenly 10,000 people at the same time will be adding items to your specific shopping basket. So that's where we see it pretty helpful. But, as I said, try to keep it simple to start. If you dive into Service Fabric, you will see it's pretty complex. It has a lot of features. That's because these complex projects are built on that. If you just have to move cloud services or have your small worker moved to Service Fabric, keep it simple. I would say I always start with stateless services, unless if there's a good reason to move to stateful or even to actors. Because with stateful services, what you also see is that it's not easy always. I mean, if you want to store your state with your services, you often lack out-of-the-box resources. If your state is stored in your SQL database, but you have out-of-the-box things, you have SQL reporting, you can use Power BI, it's really data store if you store the state with your service itself, but you don't have all those capabilities, so you have to either build that or, what we do very frequently, still offload in the background your state to one of these out-of-the-box data stores like SQL Server or DocumentDB or things like that. It's also important if you have upgrades of one version to another of a stateful actor or service that you think about state migration. If your state structure, your schemas, if you want, if they change, you have to make sure that you have that migration in place. I will go quickly here. The service type is just a combination of your code, of configuration, and potentially data that you can package. You will package it based on an XML file, and you can ship it, and you can make it part of an application type. So an application type exists of multiple services or service types, and you can deploy an application to your Service Fabric cluster. I will be talking a little bit later on how we achieve multi-tenancy in our platform. I think I talked about that one already, service partitioning. So what you see, the P means the primary. So I have a partition 1, 2, 3, 4, and each of them has 2 secondaries living on other nodes. So what happens if I just scale out? So I add 2 nodes. You will see that Service Fabric will automatically reshuffle and remove the partitions. And now you see that none of those nodes has 2 primary partitions on that. If I would scale back, you will see that things will scale back, and suddenly you have, I think, node, there's a certain node that could have 2 partitions, okay? Now, I think the most interesting part for the rest of this talk, and I only have 7 minutes left, so that's why I go rather quickly, is 4 scenarios that we have been implementing with Service Fabric. And the first one that we did together with the Azure CAT team, so that's the customer advisory team, and most specifically with Paolo Salvatori. You probably know the Italian guy from his past BizTalk history. One of those things that we have been doing is the connected building scenario. So we have customers, and also in our own office, where we monitor devices or sensors. It's mostly sensor driven. These sensors are sending through our field gateway their data to the IoT hub. So we just listen on that data coming in. And what's important then is we just push these events to the right actors. So if it's sensor in the meeting room Geneva, that meeting room actor will get that event, and they can start acting on that. And what we have those stateful actors, and actually they are implemented as a state machine. So they get these events from various external actors or services, and they can, based on the state they are in, they can take decisions like, hey, there's motion in that room, I know that the calendar update came in, things like that. What should I do? So you can define your behavior in that way. And you don't have to care about all the complexity of high availability, because you could get that out of the box. The only thing you have to work with is the state, the events you get, and the business logic. One of the things that we had to do, and I'm still not happy with that, is rely on a custom framework that Paolo has been doing mostly. That's the observable observer framework, because there's no out-of-the-box pops up in Service Fabric. So ideally, you would have your service that listens on these external events coming in from IoT Hub, and that would publish the events, like we are BizTalk people, right? It publishes its event, and then the right actors could just say, I'm interested in all the events of my lights, if I'm a meeting room sensor, if they turn on or off, and you can act upon that. So we had to work around that. Of course, the other thing that we could do is rely on what we have out of the box, and that's Service Bus, right? There we could use queues and topics to do the right pops up logic, and that's actually what we do with the last scenario that I talk about, which is Integration Cloud. So the Observer framework has been open sourced by Paolo, so on GitHub. If you go to his account, you will see Service Fabric Observer. Now, the other one is a startup that we worked with. It's called Talk to Fans. It's a Belgian-Dutch startup. And it's a new social media project where they want to have communication between sports clubs. Sports clubs can be the club of my son with, 100 members. But they also target people in the first class of soccer teams in certain areas. So you can see you can have very small groups, and you can have suddenly very big matches. And that's what I was referring to. If you partition not correctly, and that's actually what we did in the beginning. It's probably not very visible, but we said, okay, we will create an actor, a stateful actor, per event, per match that is played. And if people are sending pictures, tweets, but it's called talkies in that case, related to that specific match, we will keep them in a collection, and it will be very easy to just give back to the mobile apps the list of most recent talkies. But of course, if you suddenly would have that big match, then you will see that all the requests coming in from people tweeting, writing, they would all go to that same single threaded actor. So that's something that we had to take care to move if we want to have that big scalability, that's something we have to do. So that's one of the lessons learned that we had. Don't just use actors because it's nice, and if you do, really think about the partitioning, because that's where the scalability is defined. Another one was, and we didn't implement it yet, but it's a discussion that we had with a customer. It's a city, and they have camps. It's like your kid again. They can, in the holidays, the summer holidays, they can register for a sports camp or an arts camp or language, whatever. But what happens, it's worse than buying a ticket for Adele or the Foo Fighters or U2. People really need to register at 8 a.m. and it's like calling, and then so you have that typical issue. So they have a lot of servers just for those peak moments. But what we said, okay, we can easily have that solved using Service Fabric with multiple channels. So you could say, okay, we have automated calls. Think about Twilio, where you have a workflow that then says, okay, you're in. And think about your website or app that talks to an API. But that API is, of course, something that we consider as a stateless service. If we, for those moments, scale out to 30 machines, we will have 30 instances of machines listening behind the load balancer for those requests. If there's a request coming in, what we can then do, we have a stateful service, a ticket dispenser, that can keep per camp a list of people that need to get a ticket. So if you get a ticket, and that's the only thing it does, it keeps track of all the people coming in, and the first come gets the first ticket, the second one gets the second. It has 200 tickets, 500, depending on the camp, and then it stopped. So the communication only happens between the stateless service and the stateful service. And if you get a ticket, it's offloading that to the rest, and that's the actors. And that's just one ticket is one actor. And that, it has all the time. It can be, it can take some time. People can, with that ticket, maybe 4 hours later, come back and easily, fill out all the details because they have that ticket. And that's a system that's very easy to set up. And again, for them, they can scale down, 4 hours after that everyone realizes that his son or daughter is either going to that camp or, of course, has to do something else. Now, the last one, before I have to end, is the service that we have been working on in the past 6 years. I have been talking about that one. It's Integration Cloud. So it's an integration platform as a service. And we started back in those days on cloud services. And the most important service that we used behind the scene was messaging on Service Bus. We still will rely on Service Bus because it gives much more out of the box for everything you want with time to lives, with dead letter queuing, with PubSub out of the box, with topics and subscriptions and so on. But what we had was the things that I mentioned at the beginning. If you create a new endpoint and you have to listen on that FTP location, and suddenly you have to listen on an HTTP endpoint and do something else, we had to wrap all of that into the same cloud service, because that's the scalability box that we had. So that was pretty complex to do stop and start, and we had to do a lot of task and thread management. Also, deployment was complex. If there's one thing that we had to change in the runtime and to deploy, that became quite complex. And also the multi-tenancy. We were sharing sometimes machines for multiple tenants, even though they had their own data store, and that became complex. So what we do, we use reliable services for adapters, stateful actors if you want to do tracking. For every chain we do that. We, of course, have now multi-tenancy and high density. And what's extremely helpful is this side-by-side versioning for us. And I will show that quickly. So the first thing we do on top, you have the deployment service. So we can easily say, hey, there's a new customer, customer Y. We will now deploy a test environment for him. So the only thing we have to do is, we have to say use version 1.3 of the integration fabric, which is our service, and deploy it for that customer. And then automatically on the cluster, that specific runtime for that customer is deployed. So it's very intuitive, is the versioning. So what you can see here, it's a little bit. What you can see is that for the integration fabric type, in this case, we have version 14 until 20. We have them just provisioned. It means these packages, these application types are available on our Service Fabric cluster, and we can deploy instances of those applications. And that's what we do on the bottom of this screenshot, and that's the Service Fabric Explorer. What we do, we have a production environment for coded, and that's using the 1.0.17 version. On the same set of servers, we have MH test, a test environment for a customer, and that's a 0.20 version. So what we see is that on the same set of servers, we now have multiple versions running side by side, and if we want to update one of those environments, easily, we don't have to do the full re-imaging and redeployment of the virtual machines. We just push a new instance of that version type, and it gets provisioned. And that's very interesting if you want to have, multi-tenancy, side-by-side, deployments of different, tenants. Okay. I don't have time for questions, but I'm back in this room. Don't hesitate to contact me. I'm always happy to have a chat about this. It was a short talk. There's much more things you can talk about regarding Service Fabric, but I hope it was helpful, and see you later. Thank you.